I'm Ariella.
And I'm Grace. And today we are going to be solving the pleasant fractions problem.
In this problem, we are trying to solve the following three questions.
All pleasant fractions must have the following three properties.
From these given restrictions, we can make the equation and inequalities that represent all properties of all pleasant fractions, where n equals the numerator and d equals the denominator. For property number 1, the fraction is greater than 0, we can make the inequality n over d is greater than 0. For property number 2, the denominator of the fraction is 4 more than the numerator, we can make the equation d equals n plus 4. For property number 3, subtracting 1 from both the numerator and the denominator of the fraction forms a new fraction that is at least as large as the reciprocal of the numerator of the original fraction. In order to solve the original questions, we need to find the range of all possible numerators for any pleasant fraction.
To do this, we need to solve a system of inequalities and equations for n.
We have the equation d equals n plus 4 and the inequality n over d is greater than 0. First, we have to solve this inequality and this equation. To do this, we will first use substitution. We are going to substitute n plus 4 into this denominator. We have n over n plus 4 is greater than 0. Now, for this inequality to be greater than 0, either the numerator and the denominator have to be greater than 0, or the numerator and the denominator have to be less than 0.
Case 1.
Is where both the numerator and the denominator are positive. So n is greater than 0, and the denominator n plus 4 is greater than 0. Now for case 2, both the numerator and the denominator are less than 0. We have n is less than 0, and n plus 4 is less than 0. Now we have to simplify. For n to be both greater than 0 and greater than negative 4, n has to be greater than 0 in this case. Now in the second case, n is less than 0 and n is less than negative 4, so n is less than negative 4. These are our two solutions for the first inequality and the equation.
Now we have the solution to the first inequality and the equation, but we still need to incorporate the last inequality. We need to find the solutions for this inequality that also satisfy the solutions for the first inequality and the equation, which we have already solved for and gotten the solutions n is greater than 0 or n is less than negative 4. We can use these solutions from the first inequality as cases to solve the second inequality. N is greater than 0 being our case 1, and n is less than negative 4 being our case number 2. So now we are going to be using the case n is greater than 0 to solve the inequality, we can use substitution with the equation d equals n plus 4, plugging n plus 4 in for d over here, since they are equal. So to do that, n minus 1 over n plus 4 minus 1 is greater than or equal to 1 over n. We can simplify this to get. Now, what we are going to do is multiply by n plus 3 and n in order to remove them from the denominator position. First, we can multiply by n plus 3. Remember that since n is greater than 0 in this case, n plus 3 will always be a positive number, and therefore we do not need to switch the inequality sign. You can simplify this to get minus 1 is greater than or equal to. So now we need to do the same thing, multiplying by n to get it out of the denominator over here. Since n is greater than 0 in this case, we do not have to flip the inequality sign. We can simplify this to get a quadratic inequality and factor to get for both of the products to be greater than or equal than 0, both values either have to be positive or both have to be negative. So we can solve two options. So the first would be if both n minus 3 and n plus 1 are greater than or equal to 0. So we can simplify this by adding 3 to both sides to get n is greater than or equal to 3, and by subtracting 1 from both sides, we can get n is greater than or equal to negative 1. For n to be both greater than 3 and greater than negative 1, n must be greater than or equal to 3. For both factors to be negative, n minus 3 should be less than 0, and n plus 1 should be less than 0. We can simplify this by adding 3 to both sides to get n is less than 3, and by subtracting 1 from both sides here to get n is less than negative 1. For n to be both less than 3 and less than negative 1, n must be less than negative 1. However, in our case, n is greater than 0, and no number less than negative 1 can ever be greater than 0, so this solution will never work for this case. And this is our final answer for case 1, n is greater than 0.
Now we have to solve for case 2, which is n is less than negative 4. Remember that we got these cases from our solution to the first inequality, which was n over d is greater than 0. So now we start off with the inequality, and now we, similarly to case 1, we have to use substitution. We have the equation d equals n plus 4. We have to substitute n plus 4 into where d is. And now we simplify. rid of n plus 3 and n in the denominator position. So we have to multiply both sides by n plus 3. In this case, n will always be less than negative 4. So even if we add 3, n plus 3 will always be a negative number. So since n plus 3 is a negative number and we are multiplying by a negative number, we have to flip the inequality sign. Now we multiply is less than or equal to n plus 3 over n. Now we also have to get rid of n in the denominator position. So we multiply both sides by n. Also, because of these case restrictions, n will always be a negative number, and so we will always be multiplying by a negative number, and therefore we have to switch the sign again. So now we have n squared minus n is greater than or equal to n plus 3. And now we simplify. And factor. So now we have this factored inequality. For this inequality to be greater than or equal to 0, either both factors have to be greater than 0, positive. So n minus 3 to be greater than or equal to 0, and n plus 1 must be greater than or equal to 0. Now we can simplify. For n to be both greater than or equal to 3 and greater than or equal to negative 1, n has to be greater than or equal to 3. However, in this case, n will always be less than negative 4. So this case will never work. And for our second case, both factors have to be less than 0 or negative. So we have n minus 3 is less than 0, and n plus 1 is less than 0. Now we simplify. For n to be less than 3 and less than negative 1, n has to be less than negative 1. However, in this case, n will also be less than negative 4. So, for n to be less than negative 1 and to be less than negative 4, n has to be less than negative 4. And this is our final solution for this case. Now we have solved for case 1 and case 2 of the third inequality. And we have found that for case 1, n is greater than or equal to 3. And for case 2, n is less than negative 4. So our final solution for both case 1 and case 2 is n is greater than or equal to 3, or n is less than negative 4. We graph this on the number line.
So now we have solved for n, but we still need to answer these original questions. Question 1 asks, among all pleasant fractions, is there one with a smaller numerator than any other? If there is one, what is its value? Since for case 2 we found that n is less than negative 4, there is no smallest numerator, and n can be infinitely small.
Question 2 asks, among all pleasant fractions, is there one with a larger numerator than any other? If there is one, what is its value? Since from case 1 we found that n is greater than or equal to 3, there is no largest numerator, and n can be infinitely large.
Question 3 asks us, among all pleasant fractions, for which the numerator is positive, is there one with a smaller numerator than any other? If there is one, what is its value? Well, case 1, n is greater than or equal to 3, is the only case in which n is a positive value, and 3 is the lowest value that n could be for that case. So the numerator for the pleasant fraction is 3. Now looking back at the pleasant fraction properties, number 2 tells us that the denominator of the fraction is 4 more than the numerator. So if the numerator is 3, we can add 4 to that to get 7 as the denominator and get a pleasant fraction of 3 over 7.
Now we have successfully solved the pleasant fraction problem. As a quick review, we first came up with the equations and the inequalities that represent the restrictions of pleasant fractions. Next, we solved the first inequality, n over d is greater than 0, by substitution and cases. Next, we used the solution for the first inequality as the cases for the second inequality, n minus 1 over d minus 1 is greater than or equal to 1 over n, so we can find the combined solution. Next, we used substitution and then cases. Case 1, we found that n is greater than or equal to 3, and in case 2, n is less than negative 4. Here's our final solution for both cases. Finally, we use this final solution to answer the original questions.
Thank you for watching
And learning to solve the pleasant fraction problem with us.
Audio Jungle. Audio Jungle.
We can form the equation. Wait, can we start that again? That was awkward. Hi, I'm Ariella.
and I'm Grace, and today we are going to be solving the pleasant fractions problem. You're in your zone? You have to get
Right, bigger.
okay, I'll start up. The first inequality and the second into the third.
Okay.
Thank you for watching.
And learning to solve the
The present fraction.
pleasant fraction. Okay. Okay, let's upload this.